Okay, so this video is devoted to dummy variables, and let's start with definitions. So dummy variable is a variable which can take only two values, 0 and 1. So it is usually designed to represent the presence or absence of some categorical effect. It sounds weird, but you will get this in a second. So for instance, using dummy variable, you can analyze the effect of European Union membership on the volume of international trade. You can analyze the effect of gender on wages, because gender is simply a category, like male or female. Probably non-binary as well, but you can rarely see anything like this in statistical data surveys, so yeah, sorry for my sexism. It was not intentional. You can analyze the effect of gender on how the number of children affects wages. So basically, effect of gender on the effect of number of children on wages. You can analyze the effect of season on sales, like ice cream sales. And let's say effect of ethnicity on academic performance. Of course, the scope of potential use of dummy variables is not limited to what I have listed here. Those are just the examples we're gonna analyze in this video. So let's start with the effect of European Union membership on the volume of international trade. So what you can see here is a very simple version of the gravity model of international trade. Basically, it tells you that the bilateral trade between two countries depends on geographical distance between two countries and the product of GDP of two countries. I also added European Union membership dummy. So let's start with interpretation. So trade simply stands for the volume of trade between country I and J in period T. Beta 0 is constant. As you remember, it stands for the value of vertical intercept of the regression line. It tells you what is the value of international trade variable if the rest of variables take the value of 0. Distance is simply geographical distance between country I and country J. GDP product was calculated as the product of GDPs of country I and J in period T. And finally, EU membership dummy takes the value of 1 if both countries are European Union member states in period T and the value of 0 otherwise. Of course, you can try to come up with more options. For instance, it's possible to have a situation when neither of the countries is European Union member states, or when one country is an EU member state and the other country is outside the EU. But to be honest, we are not really interested in this at that moment. So basically saying that, 0 captures all the situations when this is not true. I mean, when both countries are EU member states is not true, will be enough for our analysis. Probably I can explain it using this example. So take a look. European Union was founded in 1993, if I remember this correctly. So Germany was the member of EU in 1995. However, Poland wasn't, because here I treat Poland as the reference country. Here all the time I analyze the trade between Poland and other countries. So even though Germany was an European Union member state, Poland was not. That's why this variable takes the value of 0. In 2004, Poland joined European Union. So now, since 2004, both countries are European Union member states. So now this variable takes the value of 1. You can analyze this based on example of other countries. Like the same will apply to Italy and Netherlands. But take a look. Russia was never a member of European Union. So in this case, even when Poland joined European Union in 2004, since Russia is not the member of European Union, the value of this variable is 0. Because, as you remember, we can put 1 only in situation when both countries are European Union member states. So this is the idea. Here is my result. I will share the data so you can do the same estimation in Gretel. So the value of coefficient is positive. Coefficient of distance variable is negative. Sorry, the value of constant is positive because here is beta 0, it's constant. So distance variable has a negative coefficient, which makes sense because we assume that bigger geographical distance between two countries diminishes the volume of bilateral trade between these two countries. This variable has a positive coefficient. So even though I divided the value of variable by 1 billion, it's still a ridiculously small coefficient. So probably I had to divide like by, I don't know. But nevertheless, it's positive, it's statistically significant. And finally, the dummy, European Union membership dummy, has a positive and statistically significant coefficient. So basically, you can interpret it as simple as it is. This dummy, when it inserted in the model in this way, simply tells you what is the difference between volume of bilateral international trade in the pairs of countries when two countries are EU member states in comparison to the pairs of countries when this condition is not maintained. So, okay, you have it here. So in this case, if the value of this dummy is 0, then the value of vertical intercept is just equal to beta 0. However, when it's equal to 1, then the value of vertical intercept is equal to beta 0 plus beta 3. So in this case, we did not multiply dummy by any of these variables. You will see why we can do this in a minute. So basically, it will just affect the value of intercept. So for instance, you can see some simplified depiction of our results here. So we analyzed the effect of distance on the volume of trade. This line, regression line, is downward sloped, which indicates the negative coefficient of distance variable. And we have two regression lines. So this regression line is for pairs of countries when condition that both countries are EU member states is not maintained. So again, it can be like two countries outside the European Union or only one country outside the European Union. In any case, it is not true that both countries are in the European Union. And here we have regression line in a situation when both countries are European Union member states. So again, these pairs of countries, like when both of them are European Union member states, will be characterized by the bigger volume of international trade in comparison to countries when this European Union membership condition is not maintained for any value of distance. The slope is just the same. So in this case, we do not assume that membership causes any difference in the effect of any variables on the volume of international trade. It simply causes the effect on international trade directly. That's why we have bigger value of intercept for the countries which are both European Union member states, but the value of the slope is just identical. So those are two parallel lines. In contrast, we can assume that gender affects both the wage itself and the effect of number of kids on wage. So that's how it looks like. Hypothetically, like this is based on hypothetical example, I do not have any nice microdata for this case. So theoretically, we can analyze wage of individual I as the function of gender, number of kids, and probably some other variables which are not included to this model, like education, age, and so on and so forth. So wage stands for the, let's say, annual wage. Gender is gender of individual I. It takes the value of 1 if the respondent is male and the value of 0 otherwise. So basically when the respondent is female, again, I'm sorry for this. This was sexist but not intentionally. And number of kids simply stands for the number of kids of individual I. So we assume number of kids to have a negative effect on wage. And I have some reasons for saying something like this, because because usually the bigger is the number of kids, the less time the person has for some education, training, and so on and so forth. Probably this person has to take more sick leaves, and all of those affect wage negatively. However, I hypothesize that the effect of number of kids is stronger in case of female workers. So, the coefficient of this variable, beta 3, will tell you what is the difference between male workers and female workers. So basically, I hypothesize it to be positive because I assume that males have higher wages in comparison to female employees. And again, there is no uniform theory explaining gender wage gap, but it's true even in the developed countries. And also, I assume that beta 1. Beta 1 stands for the effect of gender. So, and also, I assume that females will be affected more significantly, let's say, or strongly by the number of kids. So, that's how I expect it to look like. So, I assume that males are gonna have higher wages in comparison to female workers, regardless of the number of kids. So the value of intercept will be bigger, and also the number of kids will cause more significant effect on female income than on male income. So this is the idea. So yeah, employers always discriminate against workers with kids, but I assume this discrimination effect to be stronger in case of females. So that's how my regression line is expected to look like. And in order to capture this difference in the coefficient, or basically in the slope of regression line for females and males, I have to multiply gender variable by the number of kids. So beta 1 will tell me the difference between the value of intercept. So I assume to have beta 0 for females and beta 0 plus beta 1 intercept for males, because just to recall this, I assumed that variable takes value of 1 if the respondent is male. So you can just do the opposite and say that this variable takes the value of 0 if the respondent is male and the value of 1 if the respondent is female. But then probably this coefficient will be negative because females have lower wages in comparison to males. But in order to capture the difference in the slope of regression line for females and males, I have to multiply variable denoting the number of kids by the variable denoting gender. And that's how my data structure will look like. So ID of the person, annual income, gender, again, value of 1 if the worker is male and value of 0 if the worker is female. So when this dummy variable stands alone in the regression, it will just affect the value of intercept. But this is fine because that's how I assume my regression lines to look like. And this is simply the product of gender and the number of kids. So if the respondent is female, then this variable will take the value of 0 because 0 times any value gives you 0. And if the respondent is male, it will take the value 1 times number of kids, as you can see in this column. So we assume that for males, this discrimination effect against workers with children will be weaker than in case of females, because the slope is smaller here. So I assume that the coefficient of this variable is negative. It's here. Beta 3 is negative. So beta 1 is positive because males get higher wages, and beta 3 is negative because males face less discrimination depending on the number of kids they have. So this is the idea. Another thing is that you can have dummy variable with more than 2 categories. However, in this case, this technique will look a bit different. So, for instance, let's say you want to analyze the effect of season on the volume of ice cream sales. So there are 4 potential categories, seasons like winter, spring, summer, and autumn. So the number of dummies should be 4 minus 1 equal to 3. So this is the general rule. Number of dummies have to be always equal to the number of categories minus 1. Okay, let's introduce an example. So in this case, obviously, you will skip one of the seasons because you cannot have 4 dummies. So there will be 3 dummies in the model. Like season 2. This dummy will take the value of 1 if we analyze sales in spring and the value of 0 otherwise. And since we skip the first season, winter, the coefficient of this variable will indicate the difference between sales in spring and winter. So if it's positive, it will mean that sales of ice cream are higher in spring in comparison to winter. Season 3. This is dummy which take the value of 1 if we analyze sales in summer and the value of 0 otherwise. The coefficient of this variable will indicate the difference between sales in summer and winter, and obviously we expect coefficient of this dummy variable to be positive. And finally, season 4 is dummy which take the value of 1 if we analyze sales in autumn and the value of 0 otherwise. And the coefficient of this variable will indicate the difference between sales in autumn and winter. So this is the idea. Depending on which category you skip, you will interpret the coefficient of dummy variable as the difference in the variable of interest in category you analyze and the reference category. So in our case, the reference category is the first season. Another example. Like, let's say you want to analyze determinants of academic performance in Lazarski University, and you're interested in academic performance of students of different ethnicities. Like, we have Polish students, Ukrainian students, students from Belarus, Indian students, students from Kazakhstan, and Caucasian students. Sorry for this generalization, but I think that number of students of this ethnicities is relatively small, so that's why it makes sense just to combine it. So, and yeah, basically you just wanna see the effect of ethnicity on academic performance, or how academic performance varies among the students of different ethnicity. So Polish students represent the biggest group in the entire population of Lazarski University students. That's why it makes sense to skip them and treat Polish students as the reference group. So the list of dummies to be included in the model, will be according to ethnicities except of Polish students. So for instance, US will be the dummy, taking the value of 1 if the student is from Ukraine and the value of 0 otherwise. So the coefficient of this variable will indicate the difference between academic performance of Ukrainian students in comparison to Polish students, and so on and so forth. So you do the same for any group except of Polish students. Because as you remember, the number of dummies in the model has to be equal to the number of categories minus 1. Okay, so that was it, and thank you for watching.